Right. Good afternoon and welcome to this week's Iowa Learning Farms webinar. Um, hope you are all doing well today and having it's a beautiful day here in Iowa. That's for sure. And so hope I'm just taking care of a couple housekeeping items here. Okay, so I'm Matt Helmers with Iowa State University in the Department of Ag and Biosystems Engineering, and my great pleasure to get to host the Iowa Learning Farms webinar again this week. We have a very interesting topic, I think, and some work that we're helping fund through the Iowa Nutrient Research Center as well. And so we have Andrew Rupiper with us. That's a graduate research associate that works with Dr. Billy Beck and then in the Department of Natural Resource Ecology and Management. And Andrew's going to talk to us today on Beaver on the Des Moines Lobe, impacts on water quality and sediment transport. As always, if you have questions, feel free to type those in the chat box and we will get those to Andrew at the end of his talk. With that, Andrew, the virtual floor is all yours.
Thanks, Matt. Hopefully everybody can hear me pretty well. So like you said, hopefully we can talk a little bit about my research today. I included some things that are a little beyond the scope of our actual research project, just due to a lot of interest from around the state, especially around how we can mitigate the negative impacts of beaver as we talk about those positive kind of ecological, water quality and sediment impacts that we've perceived them to have over the last few years. So some of you may know me, some of you probably don't. I spent a number of my years, my 20s and early 30s, running around the world, various parts of the military. I worked in microbiology down at DuPont Pioneer for a number of years. Found myself kind of wondering what I could do next. An opportunity opened up to go spend my day in places like this behind me here, or in the picture on the slide there. So that's Catton Branch, Iowa, near Boone, one of my favorite places in the state, full of beavers, all kinds of dams, really interesting topography, really perfect kind of site for us to study beaver interactions. I also recognize, though, most of our state doesn't look like this anymore. We obviously converted it to row crop agriculture over the last couple hundred years. So we're dealing with beavers not only existing in what I would consider kind of their natural habitat, but interacting with us in this new habitat that we've created. So beavers for quite some time were persistent in Iowa. 5 to 10 million has been kind of the population estimates I've seen from the early 1800s, kind of pre-settlement time. As we encroached on their habitat, we obviously had to kind of find a way to keep the peace. Fortunately, but unfortunately for the beautiful men of the time, they turned a lot of the beavers into these now kind of silly, but at the time very fashionable hats. They were involved in, the Navy had thousands of hats commissioned from beavers in Iowa. We had a number of Native American settlements that were utilizing beaver dams as locations to fish. So we pretty quickly co-opted the beaver as a source of furs predominantly. I stumbled upon University of Northern Iowa does quite a bit of historical archiving of various scientific documents. And I stumbled on this from 1936. They could not find beavers in the state. There was like 1 or 2 up in Sioux County, a few in like Carroll County area, but for the most part, they were gone. So that's about 100 years ago. Over time, the attitudes have kind of started to shift, more so in the West Coast, and that's where a predominance of the research has taken place. Places like California, state of Washington, Colorado has had a pretty big resurgence in beaver research, led by Dr. Ellen Wool and a number of other people. There wasn't a lot of appreciation for kind of the services they provide outside of habitat for birds and things like that until recently. We're seeing some pretty significant fires out west, as we all have probably seen in the news. Not only are they finding these areas of fire act as kind of refugia for the plants themselves, but a number of animals of interest end up in those places as well. See, this whole landscape is just burnt to the ground, except for those areas occupied by beaver. They keep the water table high. They basically protect that little local ecosystem that they make their home in. We're also seeing a pretty interesting uptick in cooperative restoration with beavers. We're realizing, again, as science moves down the line and we're kind of testing all these things in the field, that no one practice is going to be sufficient to, in the state of Iowa, at least attenuate our nutrient runoff issues, as well as just kind of figuring out how to coexist with these critters. So we have to look west to find these resources. How can we work with these things to better understand how they're going to coexist with us? Fortunately, but not again, if you look at the landscape out west, we don't have mountains. Our soil is very different. It's this alluvium that's been moved back and forth across the floodplain over a couple thousand years since we've had glaciers move through. They're dealing with granite, giant mountains and things. So we have to kind of retool thinking a little bit when we're talking about Iowa. And that's really what led to the INRC funding a lot of this work. The INRC exists to try to potentially reduce our impact on the environment at a very high level. One of those obstacles is, okay, we have this nitrate coming into the state. We have these agricultural nutrients leaving the state. We can't quite account for all of those. So we kind of explore things like beaver dams as a potential location that's being sequestered in or otherwise being manipulated around the state. And then as a secondary benefit, we can say, oh, okay, we've put some numbers to this, as my boss Billy likes to say. Now, how do we kind of estimate the whole state? Can we recommend different areas that are maybe preferentially preferred to put beavers in? Been a lot of interest again, like I said. So the Cedar Rapids Gazette sent a reporter out and toured around some ponds. We look across like the big kind of global research. Most of you, if you don't spend a lot of time in academia, there are review papers that come out periodically. This is just a quick grab from one of those. And if you look in the Midwest, there's essentially no beaver research being done, even though they live in basically all 50 states besides Hawaii at this point. So we have a number of locations that we've identified beaver dams. Our study is relegated to the Des Moines Lobe because of those unique properties that exist there. So this is the prairie pothole region is another term we use frequently to describe this area. It's very heavily saturated soils that we have used things like channelized corridors as well as tile drainage to allow for us to produce some of, I guess, the most abundant per acre corn in around the world. Comes from this part of the state, as well as some other corners of Iowa. That being said, anywhere that these rivers exist, we're also going to have beavers. So beaver dams in Iowa look appreciably different than those out west. I guess the first thing I would point out, you can see they integrated pretty significant amounts of corn stalk. So this is fall, probably last year, out at the Smeltzer Research Farm, which is one of our more channelized kind of traditional Iowa stream reaches in Prairie Creek, just south of Otho. You can see they still utilize woody material. There's some sedges and grasses in here, a lot of willows taken from the adjacent bank, but they are using things like corn stalks. Interestingly, they'll also kind of roll stones up to like cobble basketball size to anchor all of this in place. It's pretty neat to see them kind of use their back legs and manipulate these stones in place. But really the kind of key takeaway here is twofold. One, they use a diverse number of species to build these dams. They use significant amounts of sediment that they're kind of packing in place to really fill those gaps where they're losing water. And if we're a little bit too close to a cornfield, they don't care that it's corn. They treat it just like a willow, cut it down, drag it, put it in their bank, put it in their dam rather. A couple other things to note here. There are no lodges in a lot of our systems in Iowa, just because these streams can't spread out into the floodplain. So they'll build dens into the banks, they'll dig holes, which can sometimes cause some erosion or kind of bank loss that we wouldn't want to see. And then in general, they're going to be pretty gregarious. They're going to move throughout the system pretty readily. They have some babies, they send them downstream, and they're going to populate another stream. So the way we start to make some comparisons is we have these two primary sites. The Smeltzer Trust Farm, which we just looked at, is very similar to the channel behind me in the image here. Just dead straight, very flat, not a lot of slope, not a lot of sinuosity or curviness to the stream. That's most of our state again. The key there is that it's disconnected from the floodplain. So even if we get a high water event, it's more than likely just going to blow that dam out rather than spread that water out into the floodplain where it can be processed by the processes we hope to invoke during floods. Contrast that with our Cat and Branch site. So it's the watershed itself. So I guess the way that you think about that is you have a stream, there's the catchment area or all the water that flows to that stream. It's only about 70% agriculture at Cat and Branch, which is a very low number for our state if you compare across the similar stream sizes. It's naturally meandered. So it's actually a protected area. It's a hunting kind of DNR owned property that the stream is just allowed to do what it wants. And the benefit of that, you can see a lot of time spent that water traveling down that long path rather than just kind of ripping straight through the line. We perceive a benefit there because all the little microbes, all the plants, all the trees are able to uptake some of that nitrate or phosphorus and keep it on the landscape rather than sending it down to the Gulf, if you will. And there are a lot of trees. So beavers are going to have a hard time persisting and building dams if they don't have trees to do it with. We like to see them in areas that have trees, or otherwise we can kind of strike that balance, or they're going to just go in and they'll take an acre of corn in a night pretty easily. So there's kind of two primary things that I look at in my work when I'm out in a stream. This is my son Reed here, junior assistant. Don't look at the Hawkeye shirt, I guess. I probably should have edited that one out for Iowa State here, but the biological activity. So anytime you slow water down, you allow biology to take action. We see direct evidence of that out in the field by nature of these biofilms, or these kind of scummy, I guess is the word I hear a lot of people use, surface conditions. We see bubbles happening from either methanogens or other critters that are otherwise chewing through our nitrate. And we see a low level of dissolved oxygen. So these are all kind of key components, along with a whole bunch of organic matter, which we have plenty of in Iowa streams, contributing to some potential, especially nitrate loss. And then when we think about phosphorus, a non-insignificant portion of phosphorus is bound to little sediment particles. It's just the way the surface charge of our sediments in Iowa works. A lot of phosphorus ends up bound to sediment particles. It can desorb and adsorb up and down into the water column. And we might see some evidence of that actually happening in beaver dam pools. But a lot of it is, if you can trap that sediment up on the landscape, we're going to keep that phosphorus along with it. We do a number of different types of sampling. I'm going to kind of skip through a little bit of that today so we can get to some of the how do we deal with the beavers in our landscape. But to say we go along kind of a a reach of stream, a portion of stream. We have one primary study dam at each stream. Beavers also tend to have one primary dam that they really work hard at maintaining. And then they have these kind of, I call them their little vacation homes that they kind of go visit every now and then. Really what beavers are doing with these dams is creating an environment that they feel comfortable living in. If you've seen a beaver walk across land, they're not graceful. They're kind of stumbling and bumbling around. In the water, though, they can cruise. They're safe from predators. They find their food resources there. And even in the wintertime, you'll see them stuffing sticks under the ice just for a little snack in February. We look at a number of different runoff elements, nitrate, dissolved and total phosphorus, as well as suspended sediments. These kind of all interplay with one another in various ways. But we look across that kind of chain of dams, not only look at what the effect of one dam is, but sometimes there are 15 or 20 dams in a relatively short length of stream, each of those acting as kind of a small wetland. We also are interested in not just what's flowing in the water column itself, but what's happening in the sediment directly below the water of the stream, kind of the base of the stream. So a lot of times we'll go out and we literally just take a probe, it's a tile probe really with some graduations on it, and we'll try to get an idea along the stream how much of this sediment is built up behind the dam. There's a lot of time spent staring at whiteboards and scratching numbers and trying to figure out the best, most error-free way of dealing with all this data. But in the end, we're pretty happy to see, okay, if you have a beaver dam in place, the yellows and reds just mean there's a bunch of sediment built up behind it. Unfortunately, sometimes we have these dams break. Of course, there's a few dams in our study areas that were 15, 20 years old. The second I started, they started breaking pretty quickly. That's just how science goes sometimes. We see after the dam breaks, though, very little sediment left in place. So on the one hand, these are great at trapping sediment. They're great at allowing the water to slow down and process, but you have to kind of balance that with Iowa streams. As we've channelized, as we've kind of modified the drainage of our systems, we're getting a lot more stream power. We're getting a lot less resiliency of our dams. There's not a lot left to kind of explore around sediment behind beaver dams. The one exception is most of the kind of studies around the world have taken place in what I'll call non-agricultural systems. So we're excited to see how our results compare to some of those papers coming out around the world. It's definitely been an uptick in research around beavers. Here's a perfect example. So up at the top here, this is a fancy graph we call a hydrograph. All it means is the higher the line here, the deeper the stream was at that point in time, which is also a product of some sort of rain event, right? So this is 2022. We're in the kind of late summer here. We had some pretty sizable rain events that drove the stream up, and we see all the water coming off the landscape trying to get down to this base level. Well, of course, we came out in May and we put all these sensors in this beaver dam pool. This is Angel, one of our undergraduate assistants, standing on top of a dam. So you can kind of get an idea of the height of that thing. It's 5+ feet tall, acres of water backed up behind it. Came back about 2 weeks later, and sure enough, it was gone. Water's now receded back down to its normal base flow level. We do see some evidence of deposited sediments and things, but likely the next rain event will just kind of remobilize those and bring them downstream. So that's a very temporary attenuation of sediment, but they build these in chains of dams. Very rarely do all of them fail. Very basic graph here. A whole bunch of sediment stored on a given date, had a big rain event, a lot less sediment stored. It should make sense when a dam breaks, the things behind it get released. And you have some kind of pulse of really heavy sediment in the stream for a short period of time. But generally speaking, in storms, you're going to have persistent turbidity anyway. So just the amount of suspended sediments and things in the soil, or in the stream channel rather. So what do we do about it? We have all these problems. We want to live with beavers because we enjoy all of the birds and the habitat and the little critters that come by and say hi. We enjoy that keeps the water table up and restores some of the riparian groundwater, so we can put in saturated buffers and other cool agricultural and kind of conservation best practices. But we also don't want them damming up our roadways or our culverts and things. So over the last 20+ years, again, especially out west, but a little bit up in the Northeast, where they've got a lot more kind of density of people and beavers interacting with each other, people have come up with these beaver deceivers or pond levelers. And here's just one example. There's a lot of different designs. So if anybody's curious, if you just hop on Google and search beaver deceiver, like you're trying to trick them, you'll see a number of possibilities here. And we actually, you'll see in a later slide, tried to do this ourselves and pretty quickly failed. That's a lot of work. It's a few hundred to close to $1,000 in some cases, but it does let you regulate the pool of the beaver dam upstream. So really it's just a pipe upstream with some sort of cage preventing the beavers from kind of blocking it. This is kind of the aerial view. And then you're setting the level of the water by the position of that outlet pipe. So you're just kind of playing a little bit of hydrology physics to determine where you want that water to go. I included a little picture here. I also do some kind of, I guess, side work for a company called AgriDrain, not to like advocate for you buying their products, but a number of organizations around Iowa build these inlet cages, not only for your field tile, but you can use them in this application as well. And they're only $50, $60, but it really helps when we get rain events. We get a lot of corn stover sticks and leaves flowing down that you want to keep out of that pipe. And it also helps keep the beavers out of it. So here's our example. So this was 1 week after we installed, I shouldn't say we, a number of undergraduates, a number of professors at Iowa State all got together and went and played in, this is Hendricks and Marsh near Nevada, Iowa. So we were able to pretty quickly draw the pool down to the level we were happy with. We had some farmers upstream that were concerned with kind of backing water up into the roads and some other things up there. So we have made a little agreement like, hey, we'll drain this thing down as long as you let us keep it in place. Because previously the dams would just get pulled out with an excavator. So you see the water flowing. You can do some calculations pretty easily to say, okay, we have this much water coming in down our stream every day, so we need to discharge this amount. It kind of helps you size that pipe. But oddly enough, came back about 2 weeks after that, and the pool is now back up to where it started. The beavers had taken 10-foot long logs and navigated them down into our pipe. So I guess the lesson learned in our case was you definitely have to cage that inlet, or else they're just going to fill it right up. And you see zero flow coming out of the bottom on that same day. I also get a lot of questions about trees. So there's not a perfect way to keep beavers from trees. They like eating trees. It's just that simple. Their diet is predominantly consistent of that cambium, or that the outer layer, that growing layer. If you ever have scraped back the bark of a tree, you see that kind of greenish, spongy layer. That's what they're eating. They're not eating the sticks themselves. They're just stripping that exterior portion off and consuming it. But they also like to take down trees to get access to the branches at the top of the tree. I've had some good success. I have beaver dams behind my house down near Ankeny. We've tried this recently where you take a tree safe paint, usually it's some sort of latex paint. They do make like orchard specific paints, and you add mason sand, so 20-ounce soda bottle of mason sand and 1 gallon of tree paint, and you just paint it on the trunk of the tree. It irritates their mouth when they try to chew on it and can cause them to pick a different tree. Now, in saying this, if you have a number of trees around an area you want to keep a beaver in, I wouldn't try to do this to every tree. They're going to have to take something. So try to let them kind of preferentially take those trees we don't want on the landscape, whether it's honeysuckle, kind of invasive, or something like hop hornbeam, which is usually a pretty abundant riverine species. We try to tell people to try not to use plastic. Beavers don't care about plastic. They'll chew right through it. It's kind of the wrapper on the outside of the candy for them at this point. I've seen plastic bags tried to be used. All that just ends up as kind of refuse floating down the stream. And then when it comes to chicken wire, on the right here, you can see a tree that's been effectively girdled by chicken wire as it's grown out. We recommend instead to use a looser fitting hardware cloth. Beavers also can't climb very well, so these don't need to be very tall. And they also don't really need to be like anchored in place all that well. So we'd really try to encourage, instead of taking the aggressive step first and just going out and shooting the beaver, at least try some sort of mitigation before you get to that kind of end, because there are a number of benefits that we've seen, whether it's, again, the birds, all the little critters that come around these places in the summertime especially, or just the beavers themselves are pretty neat to watch. I travel predominantly on the Des Moines Lobe for this work, but I'm always happy to consult via email. I don't consult is kind of a bold word there, I guess, but talk to you about your beaver dam. If you see one, you have one, my email should be both on the top of this slide as well as affiliated with the talk itself. I'd be really happy to come visit farms that have problems. We've actually had some success in the last couple of months here with a number of farms in southern Iowa where there are actually bounties for beaver during the hunting season right now, in installing either some sort of beaver deceiver or even just a piece of tile laid through a crack in the dam just to help alleviate some of the flood pressure. But we do see, if you go out in the summertime, you see places like this that are bone dry otherwise, the corn isn't looking very good. Come down to one of my dams and it's just full of life. And oddly enough, my son that was presenting earlier there, he started a little study where he's throwing golf balls in upstream and seeing if they get trapped by the dam. So we've successfully seen golf balls being trapped as, maybe call them sediment analogs or something. But if there are any questions about beavers across the state, I'm happy to, at a minimum, I can give you a resource local to you. We've got a growing network of both kind of people interested in either relocating. That's more of I recommend kind of more get some technical help in that regard. We don't want to just be grabbing animals and moving them to a new place. We have concerns about disease and things along those lines, but there are wildlife relocation people, as well as just organizations that are willing to take the beavers to a place that they might better persist. So with that, I think I'll transition back to Matt. He's going to do some kind of cleanup at the end here. I'll toggle to some slides for your various continuing education, and then I'll be sticking around for questions thereafter.
Great. Thank you, Andrew. And what great use of photos in your presentation. That was awesome.
Great.
So if you watch this webinar live and you want to earn a CCA CEU, please send your name, the name you entered to watch the webinar, and your CCA number to Elena Whitaker, and her email is alenaw@iastate.edu. Send that by 5 o'clock today. Again, alenaw@iastate.edu. And then we can go to the next slide, which should be, if you watch this webinar live, if you'd be willing to fill out this voluntary demographic survey, we'd really appreciate it. You can scan that QR code or go to iowalearningfarms.org/survey. And if you filled one out in 2023, you don't need to do it again, but if you haven't and are willing to do that, that would be fabulous. Again, iowalearningfarms.org/survey. And then put a plug in for next week's webinar, which is going to be Spencer Peck. That's a ABE graduate. He's a civil engineer with ISG Inc. And he's going to talk about designing multi-purpose drainage systems to meet modern demands. So Spencer, look forward to that one next week. All right, Andrew, we got a few questions here. The first is, how does the presence of a beaver affect the water body that is prone to heavy algae growth?
Yeah, so it's kind of one of those, you take the good with the bad, right? So anytime you slow down water, in the state of Iowa especially, you're going to have algal blooms. Now, that's probably not ideal for things that are living in that water column. It's going to draw down quite a bit of oxygen. They're going to churn through nitrate, though. So we kind of have these constant balances that we're fighting with here. I would say if you look at like the area of water that's held behind a dam, like the surface area, right? That's a limited part of what they're actually contributing. So another thing that they're doing when they dam up a stream channel is they're encouraging that water to go out into the floodplain itself as subsurface water, or groundwater is kind of the key term we use. I would suggest that the benefits from that water persisting in that sediment, where all the microbes are really taking action, is outweighed by any of the losses that we might see in the stream channel. And I'll add another plug of Iowa stream channels are just generally degraded. So you're kind of dealing with okay, we're going to add some algae over something that's already fairly, there's not a lot of fish living in our streams anymore. Our macroinvertebrates are decreasing. But then the area of the total watershed that's covered by algae is very small. So if a beaver dam is 20 acres, which is humongous for a beaver dam, each of the two watersheds that I discussed today are 7 and 25 square miles. So it's a tiny proportion that you're covering even within the stream channel. But it's something we look out for as an indicator of, oh, there's a beaver dam. It's also something we can see pretty readily from above, whether it's satellite imagery, drone imagery. So it makes my job easier. In some respects, I can find a beaver dam very quickly. But on the other hand, I do understand that there are some concerns around when you see these big algal blooms, are there some kind of negative health effects? Well, I would argue don't swim in beaver dam pools to begin with. I spend all my days doing it and come out with some weird little, itchy stuff sometimes. So, but yeah, that's kind of my thoughts around algae, at least.
What changes in nitrate concentrations or loading are you observing from that water that's moving through the beaver dam?
Yeah, so if you notice, I didn't really put any direct kind of, here's the loss we're experiencing. To be quite frank, and this is more recent revelation that Billy, myself, and talking to some other people around Iowa State, is our ability to perceive the change in that 20 acres over that 29 square miles is going to be pretty difficult. We're kind of at that margin of what we call error, right? Every time we go out and take a measurement, You statistical people can inform me further, but essentially what we're fighting with is the effective change is probably somewhere really close to that margin. Now, what we do as scientists, we go through all of that and we say, okay, we'll of course report these things that we're having a hard time perceiving, but then we'll also grab out kind of stories of like, oh, okay, but in the summertime, in low flow conditions, then we really start to see that deviating. So really it's how do you look at the year? You're having to separate storm flow from base flow. So we're manipulating and trying to tease out, okay, where is the effect? We know there's effect, but what's driving it? And that's really my responsibility. So to answer the question that I've been avoiding, really we're seeing maybe a 1 or 2 part per million difference. We have some days where it's probably greater, but we're not out there every day, to be honest. We have some days where in the springtime, if you go out to these beaver dams, it's like they're not even there. There's just like a speed bump in the stream. Now, does that mean they're bad? Does that mean they're good? It's kind of neither from our perspective. I tell people I'm kind of beaver agnostic. I'm just pretending we're just looking above and below some structure, whether it's a beaver dam, Lake Red Rock, we do this similar work in with a human dam, any of the little practices that we put in place. So there's definitively, we get consistently lower numbers coming out than are coming in, not necessarily from a single dam, but from that chain of dams. So I would say if I had to put a number to it, it's negligible, but keep in mind 1 or 2 parts per million times millions of gallons of water flowing through that system, you start to build up an appreciable, what we call load. And a lot of it's driven kind of by the hydraulics of our stream systems. They're very flat, so we don't get a lot of throughput. But then when we do get throughput, it's driven by these heavy rain events. So it's a tricky question, but I think we're pretty confident at nitrate, at least, that we're seeing, and it makes sense. Like we put crep wetlands in, we put these practices in place to keep water on the landscape, to let the biotic action happen. Why would we think that it's any different here? It's just the scale of the watershed to the wetland is pretty small.
Okay. Are you seeing riparian tree mortality associated with the persistent high water caused by the beaver dam?
Yeah, so I try not to think about it as persistent mortality, but rather a restructuring of the species classes that fall in these areas. So in a channelized stream, you can put really any tree right up to the stream channel there for the most part. As we start to flood those soils, there are species that prefer that: cottonwoods, willows, some silver maples and the like. It also happens that those species have a tendency for what we call coppicing, or when a beaver comes in and chews that tree down, it's not like it's pulling up the roots and everything out of the ground. So that tree will regrow in a pile of shoots. Any of you that, my wife always lectures me when I prune my trees, I don't do it right, and then we get all these little suckers growing. It's the same principle there. The beavers are just very good at, okay, I'm going to go this far from the stream because I feel comfortable. I'm going to eat everything in that area. I'm only going to travel out further if there's some really tasty stuff out there. So we can, if you want to get around that, you can either preferentially protect the trees you're really interested in. Good luck, I'll say. I mean, it's sometimes a losing battle, but also I would argue that anytime we can saturate those areas, it might just, okay, now we're transitioning from oaks and hickories to cottonwoods and willows or something along those lines.
So this one, some people might be discouraging beavers from occupying a reach of stream, but
Sure.
Somebody had what might be some ways to encourage beavers to start occupying a stream reach?
Yeah, that's an excellent question. So I would encourage people, if you have the opportunity or the flexibility, the Smeltzer Learning Farm, it's very connected to Iowa State. We have a ton of research that takes place out there, but they periodically will have what I call kind of farm visit days put on by a number of different organizations, including INRC and others, or Iowa Learning Farms rather. Well, if you look out there, oddly enough, so over the years, they've done various practices in the stream channel. They've dumped in kind of what I'll call cobble and rubble, or what's the word I'm looking for there, Matt? The typical Iowa chunks of concrete.
Riprap. There we go. Yeah, civil engineer can come through with that one.
I'll leave it to you guys to discuss the fake stuff. But so we put these I guess, swaths of riprap in streams to kind of simulate that ripple pool run dynamic that we would hope to capture some sediment behind, among other things. Well, beavers come into the system like, oh, that's a nice little foundation you started for me. And they start to build atop that. I haven't done any sort of a true analysis, but I can tell you pretty reliably any area that's already eligible for beaver, so it has some trees, it's got a relatively low bank compared to the water surface, they will preferentially select those areas, whether it's riprap that you've intentionally placed there, or we have areas of our stream channels that naturally just kind of expose these glacial deposits, as well as just down trees. You find a big down tree, well, beaver says, oh, this is nice, and they'll start to build using that as part of their resource. So to encourage beavers, you either just throw a bunch of rocks in the stream, which is not very technical, or you can actually use what are called BDAs, beaver dam analogs. They're meant to like be installed by humans. So you're putting in various sticks and weaving in, you're basically trying to replicate a beaver dam. Again, just like the riprap, the beavers see that like, oh, somebody got a good start. They're not very good at it because they're people, but we'll kind of build from here and they'll take those over. And to be honest, if you need a beaver, there's plenty of them in southern Iowa and Sioux County, all the way to Potawatomi and the like that they're trying to get rid of. So I don't suggest you drive down there and try to capture a bunch and bring them home, especially outside of trapping season. But there are probably people out there that have the various licenses and technical understanding of how to move those beavers to your farm, if that's something you're interested in.
Okay. Next question was, is there amount of variation in dam height and grade control or potential breach of the dam frequency?
Yeah, so it's kind of a function of the geometry of the stream. So if you have a really flat stream, it takes a very small incremental height of dam to back up water a really long ways. It's kind of Pythagorean, right? So you're making a triangle. Surface of the water is always flat, essentially. You have the slope of the stream, and then you have that other axis of the triangle there. Well, beavers are trying to maximize that pool volume. In the case of a channelized stream, they can only go upstream. There's no lateral appreciable gain that they're going to get. The same issue, though, applies when you're talking about like stream power. So we have a pretty simple calculation we can do and say, okay, we have this geometry of a stream channel. This is the surface material. How much water is coming through there and what kind of energy does it have? Well, for better or worse, it tends to intersect right at that dam is tall enough where the beavers are happy that with the pool length, and it's, if we built it 1 inch taller, it's just going to get overtopped and ripped away. They've got 30 million years of experience. We've got 200 years of experience in Iowa. So like, it is amazing to me that they'll build these dams where the other end of it's so far away, there's no way they can see if it's at level. But if you shoot RTK, really accurate GPS, along that beaver dam top, it's within like a centimeter, 100 meters away. It's pretty amazing. And they're using the water as a level, right? Like they build a little section of dam. They say, okay, well, this is slow water here. It's still moving fast here. I better build this a little taller. And they keep playing this game until they have a rain event and says, okay, well, that's my maximum because it wiped everything else above that. And then they'll just really secure whatever that kind of optimal happy medium is. It's amazing to watch over time. And they're also good at like, I'm done. This site is terrible. I've exhausted all the trees behind me. I'm going to move on. And they just find a new place. But it gives that place 10 years to regrow so their pups can go so it's just this constant cycle if we can allow that to happen.
The original dam engineers.
Right.
Yeah. Okay. Can you go back to your contact slide? Somebody asked if you could show your your email again. So yeah.
First initial A, last name Rupiper at iastate.edu. And anytime, day or night, I'm always up thinking about these things. So I encourage distractions from the work I'm supposed to be doing because I can always tell Billy, oh, it's beaver related.
There we go.
Go check out a pond or whatnot at your farm.
Next one was, how often do you actually see beavers when you're out in the field?
Yeah, so they're predominantly what we'd call either crepuscular or even coming out only at night, but they don't tend to enjoy the daylight. They recognize they're much safer at nighttime for the most part. But I've taken recently to like really creeping into some of our sites that I know where their dens are at and I see them every day now. The neat thing, if we don't see beavers, we tend to see muskrat, otters in a lot of the stream channels. They're kind of, beavers create the residence and they rent it out to the muskrats. Like they're the landlords and the tenants kind of situation, and they cooperate with one another. But yeah, we see at our more natural site, I see them every time I visit. When I bring a bunch of noisy undergrads that are like talking about their weekend plans, and as we're walking in there, we see less of them, but they're pretty skittish. You hear the slaps though pretty frequently on the water surface to tell everybody else to run away. But just about every time we visit, as of late, we've started to see them as we learn their behavior and kind of patterns.
Somebody asked about that you mentioned that in the dam, a lot of them don't have the lodge there.
Yeah.
I think you mentioned that then many times they'll have a lodge in the stream bank adjacent to that. Is that correct?
Yeah, so it kind of makes sense again, where beavers build lodges in, if you read your kids a book about beavers, it's going to be out in Colorado or up in Canada, where they have these very expansive meadows that they're creating. And again, like in a mountainous situation, beavers can convert what is otherwise just a stream channel to this whole meadow complex. And it's really evidenced if we look at the kind of very beginning here, when you see a place like this, right, where you have this big wide floodplain, and it's just wild, right? Like you don't see farms, you don't see people cruising around here. There's a little road or something down there, but beavers will build lodges out in these big floodplains. So we actually do have lodges at Catton Branch, the image behind me here. Whereas in those channelized reaches, there's just nowhere for that water to spread into the floodplain. So they don't have the circumstance where they would build that, but they still need a home. So they'll instead say, okay, well, I can't build a lodge because it just get washed away, but I can dig through sediment pretty easily, which is again, that other contrasting, they can't dig out in Colorado. It's granite, right? There's no alluvial sandy soil that they can easily kind of navigate. But they'll also, as they're kind of digging those lateral burrows, every once in a while, they'll have some collapse and they'll have to move that around. So you usually will see either dam failures or bank failures, not right adjacent to the beaver dam itself, but upstream where they have those lodges. They very rarely live on the dam. They're living up in that pool created by the dam.
I guess you've looked at that sediment trapping, and there was a question: does a beaver dam remove a measurable amount of phosphorus in that trapped sediment?
Yeah, this has been the most interesting one as of late. So, I came from a background of, yes, environmental science, but it's a very broad. So I worked in like butterflies in the past and other kind of silly little prairie plants and things. I wandered around and chased grasshoppers. Here we have a much more I shouldn't say easily, we have a very defined set of parameters we're working in. The issue is when you come to grad school, you don't have, you have the information you brought, right? So you're kind of looking at these problems and trying to understand them. And then you learn more and you learn more and you're like, oh no, I'm learning what I didn't know before. And this is one of those examples where if you asked me a year and a half, 2 years ago, I would say, yeah, they trap a whole bunch of sediment. You just go walk there and you're standing in all this mushy, nasty, smelly sediment. Of course, some of that is containing phosphorus. But if you look at the examples I showed, very quickly those dams break, we get high flow events, and it just kind of gets washed to the next stage downstream. Now, some of it's going to get deposited and it'll stay on the landscape, sure. And we're trying to kind of understand what fraction of it does. It's very small, but it's appreciable. The other thing that I didn't appreciate until more recently is if you have a kind of stagnant pool of water and you have a whole bunch of sediment, constantly there's this fight for electrons of where can we desorb up into the water column? Can we adsorb down into the sediment? And without kind of getting down the road of those fun, fancy terms, essentially what I'm saying is there are periods of the year where the conditions are right, that this trapped kind of particulate sediment is actually contributing up into the stream channel, dissolved, or DRP, dissolved reactive phosphorus. Phosphorus comes in those different forms, so it's really kind of tricky to follow it from point A to point B like it is with water-soluble nitrate. So I would say on the whole, there are some contributions by the product of bank failures, those kind of dam failure rushes. There's some kind of pull out of the system by those depositional events that happen out at places like Cat and Branch. On the whole, though, it's probably pretty close to a wash in a channelized corridor. We see some overall removal out at places like Cat and Branch, because when it floods, the water moves out into the floodplain, stays there, evaporates, and it just leaves the sediment behind. But again, it's going to flood again the next year, and it's probably going to reorganize all of that stuff across the landscape.
Okay, we got one here that, might not be quite in your wheelhouse, but this individual asks, this is likely an idealistic question, but could you foresee the day where we potentially provide, incentives or cost shares for farmers for preserving beaver dams on their land?
Yeah, I would kind of take the question up a notch in the trophic level and say, so I'm a native Iowan. I came back to this state because I wanted to raise my kids here. I want it to be better every day, right? I also understand, as a native Iowan, our economy, our way of life is driven by corn and soybeans. So there has to be a balance at some point. We all recognize that the path we're on is pretty unsustainable. That's why organizations like the INRC exist. I would argue also that there is no one practice that's going to solve this problem. What I would like to see is a cooperative understanding of, okay, the people down the hall from me that install saturated buffers or bioreactors, okay, can we couple that with planting a bunch of trees locally? So when we need to restore those wood chips in 10 to 20 years, we can chip them right there. We're not having to extra CO2 or anything. We're just locally dealing with that problem. Well, guess what? If you have a bunch of trees there, you can also have a beaver there. I'd like to see a little more complementary approach. And then if I have to get on my little soapbox, because you've given me the ability to do that here online, really the big thing for me is getting that corn away from the stream channel. It doesn't have to be a lot, but this idea that we're just going to plant right up to as it's falling in and your planters hanging off the edge, it's kind of silly in my opinion. And I am a corn and soybean farmer. I kind of live in both worlds. I get it. I want to maximize every dollar that I can get. So, someday I can have my kids take care of me or something. I don't know. But in the end, I think we're realizing, and as we've progressed in our understanding of all of these things, which is fairly new, if you really think about it, I think there's more service to the cumulative effect of a number of practices than any one incentivized practice. But anything you can do to beavers is kind of cool in my opinion. So
yeah, and I keep looking at the picture behind you and reminded of a conversation last week, because I probably would have said last week, oh, look at the habitat behind you, but really it's look at the the ecological system that you're providing benefits for, a lot of different things. So we can talk about some of the water quality, but you talked about how this is the beavers are kind of providing a place for some of those other other animals to live and thrive. So it's really quite cool.
For me, it's all about heterogeneity, right? Anytime you have the same thing everywhere, you're not going to have much diversity in any fish, amphibians. You break up that system and provide it with some disturbance, like, oh, shoot, you get all kinds of things showing up. Anybody that's a birder, if you want to check off some of those rare water birds, go to one of my dams. I see them all the time. And I get people like, there's no way you see this stuff. And sure enough, like all my little iBird results are around beaver dams. All the cool birds show up there. So yeah, it's neat to see more interest in these things, I guess.
All right. So in the interest of time, not to keep Andrew on too long, I really want to thank him and also highlight that this webinar, I did remember to hit record as we started. So that recording will be up on the website. There were a couple of people that were on their phone that said they weren't able to see the slides, and I just encourage you to go back and listen to Andrew again, but definitely take a look at the slides. He's got some great photos that I think illustrate some of the benefits that we can see from this. So again, thank you very much for all of you for attending. Thank you, Andrew, for the great talk, and hopefully we can get you back on again to talk about this some more in the future.
Yeah, I'll just leave you with, in the fall is kind of my last semester in this work. I'm going to be staying on at Iowa State to do some other work in a different lab, but I'm going to be continuing to kind of keep an eye on these things. So feel free, and I'll have the big results will be this fall. So hopefully we can
We'll
disseminate
get you.
those.
All right. Well, we're gonna twist your arm again to come back this fall for a webinar. So
Pretty
thank you
easy
so much.
twisting. Thanks, Matt.
All right. All right. Thanks a lot.